I'm Carla Cutrano, performing my PhD thesis on computer simulation at the University of UOI. In this video, I will show you how we perform simply density functional calculation on a tiny icosahedral cluster like this. Density functional theory is based on Hohenberg-Kohn theorem that states that the total energy is a function of charge density. We started with the position of atoms. We choose appropriate electrons that describe copper and iron, and we write the charge density. Starting from the charge density, we calculate an effective potential visible for all electrons. We solved one electron Schrödinger equation in order to take a new orbitals and new eigenvalues. After, we write a new charge density and we compare the new and the old charge density. If our criteria is satisfied, we proceed towards energy minimization. Otherwise, we start again. Energy minimization means that the atoms are moved in order to get forces zero, as is shown in this video. Our results are plotted in the electronic density of state, which show how many electrons exist at a particular eigenvalue. We plotted separately spin up and spin down in the case of copper and the iron. We can see that in the case of the copper, spin up and the spin down are symmetric. On the contrary, in the case of iron, we can see that spin up are occupied and spin down are totally empty, revealing the origin of the magnetic moment. In addition, we can see that spin up show 4p iron orbitals and the spin down show 3d iron orbitals. These results are more clear in the next transparencies, where I will show you the wave function. Like I said before, spin up wave function show 4p orbitals of iron that are bonded with the 3d orbitals of copper. This hybridization, we can see this hybridization in this red lobe, while we can see completely different behavior in the spin down wave function. We can see, like I said before, in the electronic density of state that the iron show 3d orbitals, that we can see here an hybridization with the 3d orbitals of the copper, and in addition we have these two orbitals that are left open. They are two dangling bonds. This calculation is repeated for different sizes of the cluster and for the iron monolayer on copper 111. When the number of atoms increases, we can see the difference between the HOMO up and the HOMO down in the wave function. Also, in this picture, we can see that the smallest magnetic moment is shown in the highest magnetic moment is shown in the smallest cluster, and the magnetic moment converge to the iron monolayer when the number of atoms increases. Now, let me show you how we perform our calculation. Here I will show you our computer cluster. Consisting of 400 CPUs, and how you can see, it is homemade. Thank you for your kind attention.